So it says, when you have a power of a power, if you're raising a power to another power, so if you've got some kind of like something here with another exponent on the outside, the rule is that you multiply the two exponents. Let's see why that works, because I think that that's important to understand. So the first thing that I'm going to do is I'm going to write out the rule. So when you have a power raised to a power, we need to multiply exponents. But I think that we can do something different. Okay. So the rule says that you take the exponent inside the parenthesis and you multiply it by the exponent outside of the parenthesis. And 2 times 8 is 16. God bless you. Now, I will tell you that this is probably, in all of my years of teaching this is probably the most confused rule, and this is the one that we make the most mistakes on. So I want to show you why this happens, and maybe if you like expanding, it'll work better for you. So I'm going to rewrite this problem, and I'm going to explain it a little bit differently. So the problem is x squared to the 8th power. Well, what does it mean to take something to the 8th power? If I'm taking something to the 8th power, what does that mean? Yeah, you multiply it by itself 8 times. What is being taken to the 8th power, Hayden? What is in the parenthesis that's being taken to the 8th power? X squared. This is what is being taken to the 8th power. So I'm just going to write that times itself 8 times. So x squared times 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 x squared. And I think that that's 8 times. And we learned a rule that says when we multiply powers, if the base is the same and all of those bases are the same, what do you do to the exponents? Yeah. If you multiply, so I'm just going to write this down. If you multiply powers with the same base, you're going to add the exponents. So I'm just going to add all these little guys together. So what is 2 plus 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 2? Anyone? It's 16. So that's why this rule works the way it does. Okay. So the next one, it's good to know the rule because otherwise it's really hard to show this, right? So I have this power being raised to that exponent. So what is being raised to the -4 power? This is being raised to the -4 power. But the rule says that you do what with the exponents? What's the rule that we just learned? It says you do what with the exponents? Yeah, you multiply them. So this is the same thing as saying y to the -3 times -4. What is a -3 times a -4? It's a positive 12. Does anyone want me to expand that to show you why that works like that? So it's got no, you're good with the whole multiplying them? Okay. The last rule is having a product. We have a product, two things being multiplied together inside of a parenthesis with an exponent on the outside. Okay. So when you have something like that, you're going to take that exponent and you actually distribute it to each term on the inside. You're going to distribute the power. So let's look at what we have. This is our product. This says 4 times x cubed times y times z. The whole thing is being raised to the third power. So I have to take that 3 and I have to extend it to every single term with multiplication. Sir, I'll go back to it in a second. I'll put it back up in a second. So what did we do yesterday when we had to multiply or add exponents and something didn't have an exponent on it? What did we do? It wasn't a 0, a 1. So every single element has to have an exponent. So if it doesn't have one, put a 1 there. So really that 4 in the product is 4 to the first power. The x has a power on it already, it's cubed. The y is to the first and the z is to the first. And then you're going to distribute. And remember, when you distribute, that means multiply. Do you guys remember distributing? Distribute was something like this: 3 times x plus 2. You multiplied. Do you guys remember doing that? This is distributing, right? So that's what you're going to do. So we're going to take this 3 and multiply it by 1. What is 3 times 1? 3. So that becomes 4 to the third power. We're going to take this 3 and multiply it by the 3 on the x to the 9th. We're going to take this 3 and multiply it by the 1 on the y. 3 times 1 is 3. And we're going to take this 3 and multiply it by the 1 on the z, which becomes z to the third. So again, I'm going to show you why this works. You can or can't write it. I mean, you don't have to write it down, but I just think it's important for you to see why it works. This whole thing is being taken to the third power. So this is really 4x cubed yz times 4x cubed yz times 4x cubed yz. How many 4s do I have being multiplied together? That's why it's 4 to the third power. How many x's do I have all together? 3 plus 3 plus 3 is 9. How many y's do I have? 3. And how many z's do I have? That's why this works, okay? These are the same. So let's practice it again. So let's talk about what we want to do first. First, you want to put exponents of 1. Put an exponent of 1 when the number or the variable doesn't have an exponent on it. So what should I put right next to the 7? A 1. And what should I put right next to the x? A 1. And does the y have a variable? Yeah, it does. Okay. So remember what we're going to do. We're going to take this exponent that's on the outside and we're going to multiply it by each exponent on the inside. So I have 7 to the, let's see, negative 2 times 1 is negative 2. And then I have x. We're going to talk about the x next. Let's see, negative 2 times 1 is negative 2. And now we're going to do the y term. -2 times -2 is a +4. Okay. So I erased my bunk bed, but we did a warm up like that this morning. Logan walked us through it. What happens when you have negative exponents? What do you have to do with them? Move them to the bottom. So I'm going to put a fraction bar here. I'm going to move this guy to the bottom so it's happy. I'm going to move this guy to the bottom. So now it has a happy exponent. And this one stays right where it is on the top. Are you okay with that? Do one more example. One more example. So what do I need to do first? Which number in this expression does not have a exponent on it? The 6. What am I going to put there, Madeline? 1. Put a 1 on it. Okay. Zach M. What do I do with this -2 outside of the parenthesis? I'm going to distribute it. I'm going to take it and multiply it by every exponent inside the parenthesis. Okay. All right. So Peyton, tell me about what happens to the exponent that's attached to the 6. -2 times 1 becomes -2. Good job. Kimber, tell me about the exponent that's attached to the x. -2 times -6 becomes a negative times a negative is a positive. Good job. Let's see. Mary, tell me about the exponent that's attached to the y term. -2 times -7 becomes 14. Awesome job. Madison, tell me about the exponent that's attached to the z term. -2 times 0 becomes just a 0. So anything times 0 is still 0. So now we have to simplify that because we do have a negative exponent in our answer and we're not allowed to leave that. So what do I have to do with this? Put it on the bottom. So this 6 to the -2 power is going to get moved downstairs. Now it's got a positive exponent. Is the x to the 12th power good? It is. Is the y to the 14th power okay in the top? Yes. What about this z to the 0 power? What is that? Anything to the 0 power is 1. We learned that yesterday. Anything to the 0 power is 1. So does this change at all if I multiply it by 1? No. So we just leave it. Anything times 1 is just that. Okay. So this power of a product and power of a quotient, they're the same thing. It's all this is saying is if you have a fraction, you're going to do the same thing. If you don't have an exponent on the terms in your fraction, put a 1 there, and then you're going to distribute that power. You have to distribute it to all the terms in the top of the fraction and all the terms in the bottom of the fraction. Okay? So this first example, I don't have anything on my 3 or on my 5, so I'm going to put a 1 on both of them, an exponent of 1. And then I'm going to take that 2 on the outside and multiply it to both exponents. So 2 times 1 is 2, so I end up with 3 squared. And 2 times 1 is 2, so I end up with 5 squared. If you don't understand why that works, remember you can always expand this. 3 to the 5th, or sorry, 3 over 5 squared is the same thing as 3 over 5 times 3 over 5, which is 3 squared and 5 squared. Okay. So the last example, tell me what I'm missing. What do I need to add? I'm missing something. What do I need to add? I need to put a 1 on the 2. Good job, Mary. So that means that I need to take this 2 on the outside and I have to multiply it to the 1 that's on the 2, the 5 that's on the A, and the 7 that is on the B. So what is my new exponent that is attached to the 2? What is the new power on the 2, Gavin? 2 times 1 is 2. Okay. Alicia, what is the new exponent that's going to be attached to the A? 2 times 5 is 10. You're fine. Don't apologize. Last one, Austin. What is the exponent that's going to be attached to our B? Say it again. I'm sorry. 14. Very nice. 2 times 7 is 14. Okay. So that's how that works. So so how many of you guys have your worksheet done? If you need more time on your worksheet, raise your hand. More time. Okay. So let's just check the worksheet that I gave you yesterday on Tuesday. All right. Does that make sense? Okay. So I'm going to go to the module.